మట్టిలో నేను టూల్ అవుతుంది ఐడియా ఉండదు చాలా ఈజీగా ఉంటుంది రాసుకోవడం ఆయన ఎటువంటి ఒకసారి అట్లా ఉన్నాయి సార్ కనపడట్లేదే అట్లా ఉందా లేటెస్ట్ ఎంత పెట్టేది Hello. So, good morning once again. So, now I don't want to give any lecture, but we'll be having a hands-on session. So, what we'll be doing here is I'll take two examples for how to for regression model especially. So, how to use MATLAB to predict? I will basically take an example for sine wave. We know that y is equal to sine omega t, right? For different values of t, I will be taking the values of y. And how this function can be fitted using neural networks. That is one example. And one more example based on this session. So I will be just taking few parameters related to the network like delay or maximum retrieval limit something. And I will be predicting some parameters for TCF protocol. So these few examples I will take. So if it is open and if the MATLAB toolbox is ML toolbox is installed, you can try this. Yeah. So what I do is now y is equal to sine 2 pi x. So this is the function that I take, and I take x equal to different values. So let me take x equal to, and the sampling frequency is 1000 samples I'm taking. And I'm plotting y is equal to sine జూమ్ చేయమన్నా sine 2 pi x. So once I run this part of the code, so I got I got 1001 values for X, and for those values I have computed the values of Y. As we know, this is a very generic function. I am also plotting this. Plot Y comma X, sorry, X comma Y. So here the X label is time, and Y label is magnitude. So if I run this, so this is the sine wave that I got. Let me just also switch on the following. Is it working for you? Is it working for you? So once I run the small part of my main interest is here. You can see. So here the x-axis is the time. I have taken values from 0 to 1, and for every value with respect to the x-axis, I will get a corresponding y value. I think you are understanding. There isn't anything new in this, right? But as an example, how can we use machine learning to predict the value of y, taking this data and using this data and training a model, and how can you predict the value of y? Let us check. Actually, MATLAB, no need to write any code for this separately. Of course, you can find number of code, but the MATLAB itself has an inbuilt tool. Go to apps. So under the apps section, search for neural networks. Search for neural networks. You follow? So under neural networks, you will find different blocks for different purposes like clustering, fitting, pattern recognition, time series. So this predicting regression comes under the fitting. So there is a block called as neural net fitting. You please click on that. So a separate window will pop up like this. The following a separate window will pop up like this. So generally, you know that a machine learning algorithm basically takes data. What is this data is? This data should have it should be in such a format that it should have both the input and output. So let me consider the data here. So the data can be considered as X and Y. So where X is the input and Y is the output, this together is called as the data, and I use the same here also. So you can just import the data. There is an option called as import. So once you click on the import, you will get an option. So from your data, which is already in the workspace, which is X and Y, you can choose what are the predictors. So the predictors are nothing but the inputs, and what are the responses? Responses are nothing but the outputs. So here in this case, X is the input and the response is Y is the output. So let me just click on OK. So now the data is being loaded. You can check it on the right side. So 1000 samples of X and 1000 samples of Y are being loaded. You know that considering that this combined data is 100%, as per the standard norms, we use 70% of the data for training, 15% for validation, and 15% for testing. And the basic architecture of the machine learning will be like it has an input layer followed by multiple hidden layers, and finally an output layer. Every layer will have a activation function. By default, I think the activation function is chosen as a linear function, but you can choose activation function that I will show you later. So considering that how many hidden layers will be there, you can choose then as many number of hidden layers, but by default it's 10. I'm just going with it. Now with this data, I'm considering 70% of the data for training, 15% for validation, and 15% for testing. Let me click on the train button. Yeah, the training is completed, and you can check that the mean square error. So let me just show all the statistics related to this training. First, I'm just showing the plot for training state. So here the gradient, you can check it as the number of iterations. The gradient is falling. Obviously, it has a it resulted in very less MSC value. And checking with the performance, the mean squared error. So for how many iterations? For 350 iterations, the mean square error is almost 10 power minus 9. It's really good. It is tried almost good. Okay. And error histogram. These are the different type of statistical results that are part of your simple training. So coming to the regression part, that means how well the regression happened. That means how well the output is predicted. You know that you see here, this is actually the output Y and the input X. So the relation between the input and X is almost linear. I'm speaking in terms of data. But you can also check that how if you are fitting it. I mean, if you are predicting the value of Y, it is also almost linear because it's a sine function. Any machine learning algorithm can easily understand. That's why it's always overfitting. But just for example, it's okay. Okay. So then coming to the fit, you can see actually the sine wave and the different colors are the different points that are predicted by the machine learning algorithm. They are both coincided because, as I said, it's very obvious. Sine wave can be easily fitted. Okay. So once you use this type of GUI tool to train or to get your model, you can also do the same with some MATLAB programming. But no need to write from the scratch. This toolbox itself will give you a small snippet of the code. You just check it. There is an option called as generate code. Yeah. So under generate code, click generate simple training code. Later we will see again generate comprehensive training code, that we will see later. First click on generate simple training code. So yeah. So this is the code that is directly given by the MATLAB. No need to write by yourself. It is directly given by the MATLAB. But you have to understand. In this example, what are the inputs? time, that is x, right? And what is the output? Y. Of course, how they are related? They are related in terms of sine function that we know. So here, what is this algorithm? This algorithm don't know it. Whatever the code that I will show you, it doesn't know. Basically, it is a sine function. So what I do is, let me just explain you this code. So here, what is this x is? What is actually your observation? That means what is actually the input. So my x is always the x. I mean, where my input and output are stored, my input and output are stored in the workspace. So from this workspace, it automatically takes. So this x, which is actually the input of the machine learning algorithm, is the variable x itself, and t is actually the response of the architecture, machine learning architecture. So what is t in my data set? It's y, right? So these two I am using. And actually, machine learning, there are n number of different type of algorithms. By default, one of the famous algorithm in MATLAB is Levenberg-Mark algorithm. So that is given by a training function called as train LM. LM stands for Levenberg-Mark algorithm. Okay. But there are different training functions also, like train BR, train SCG, and different activation functions that I will show you later. But you choose a training function. By default, it will be train LM. And how many number of hidden layers I have to choose? You can choose, because the more number of hidden layers, it takes time to compute. But for simpler tasks, less number of hidden layers is permissible. It is completely depends upon the problem that we are taking. Then you can check it. I'm creating a network model because once you train, you will get a model, right? You will get a machine learning model. So this model will take the hidden layer size as well as the training function. And once you have a you have a network model, how much amount of data should be partitioned? As the standard rule says that 70% of the data should be for training, 15% for validation, and 15% for testing. But it's a standard, but it depends upon again your problem. You can use any values. Now, based on all these constraints, you can train your network by using a function called as train. So this train takes, what are the points that takes? So this net is called as a ML model. ML model has an input and output. So as for the program, what is the input? X is the input and T is the output. So this train takes three functions. That is the model, the input, and the output, right? And it gives the final trained model as the output. So now, once we have a trained model, you can just test the network using what? You have a network model, right? Net of X. This will give the value of 1. And if you want to get the error, G subtract and all, these are some performance metrics. First, let me run this and show it to you. On top of this also, let me just. I'm also copying this code here. My sine wave example I'm copying here. Okay, first let me run this my virtual example. So I'm running the virtual example. So this is what the output of the mathematical equation. Y is equal to sine 2 pi x. But now for the same x data, let me just train. I'm running the second section, that is this section. So it is training. Once the iterations are finished, yeah, I got an output. So now the entire model is trained and the name of the model is called as net. Okay. Now what I do is, So how many samples I have on x-axis? 1000 samples, that is 0.001 to 1. So these are the samples, right? Now I want the value, I want the predicted values. I want the y, but I should not use sine as a function. So I have already trained my model. What is the name of my model? Net. So now I write y is equal to net of x. If I run only these two lines, I am just running these two lines. I got a different values for y. Let me plot this for you. I am just plotting it for you again. I'm holding the previous graph as it is. So you know that the previous, you please check this. This is the previous graph that I got, which is blue in color. Now I got the y shows all the predictions corresponding to all the values of x. And if I run this part of the code, so this is what the output I got, the orange graph. So what does it mean? This orange graph I got by using these two lines. In these two lines, what does this net indicate? Net indicate my machine learning model. While training, when you just take a machine learning model, but before training, it takes both the input and output for understanding. Once the model is trained, then whatever the input you give, it predicts an output. That's how the ML works. Okay. So that's why if you see the output that I got, so this output, what I'm showing here, the orange obviously is same as the blue line, because generally the machine learning overfits for obvious functions. But let me zoom it for you so that you can understand. You see here, if I zoom it more precisely, there is a differentiation between the blue line and the orange line. So what does the blue represent here? The plot using a sine function, a mathematical sine function. And what does the orange represent? The prediction given by a machine learning model by taking the data that I have given. And the ML model by default don't know that it's a sine function. That's why it has predicted some values, but it closely matches to the original function. Obviously, there is a difference, right? But on a overall view, both are the sine waves, right? So this is how. So you can employ the ML models in MATLAB to predict for regression problems, not only for regression, but for classification, clustering, in any kind of problems, you can use this ML. And no need to write any separate codes also, because MATLAB has its own GUI model, and which also gives a snippet of the code which you can directly incorporate in your own program. Okay, let me take one more example related to the communication systems, especially related to the DCF. Here, what I did is, what I did is related to the DCF. See, whenever a Wi-Fi is transmitting, whenever you are transmitting some data over Wi-Fi, the data is generally categorized into 4 types. One type of data is VO stands for voice, or VI stands for video. The another one is background data, right? Generally, these are two background data. It can be any mails or any movie that you are downloading. These are generally the background, which should be given the priority. It should be given the priority. For example, you are making some bank transaction. Is that be given a priority, or if you are watching a movie, that should be given a priority? The bank transaction should not fail, right? It results in loss of money. So generally, the traffic is classified like this. So if you are doing a bank transaction, then the communication happening should have some priority, right? That priority can be set by using some parameters like contention window minimum, maximum, retry limit, or many parameters. Okay. Now what I do in this machine learning example is I have some voice data traffic, different categories of data traffic. I also take that the entire Wi-Fi network. So what is actually the transmission success rate for voice? Let me for other categories. I also consider that how many number of collisions occurred, and what is the average delay, and what is the throughput. I take all these parameters as inputs. Based on all these parameters, what values should I choose? That means what values of CW mean and of retry limit I have to choose. That I will predict. So next time, once you train a model using this dummy data, once you train a model using this dummy data, then next time, if actual traffic comes into picture with some delay, with some success rate, with some collisions, then the model will predict some optimal values of DCF that can really help the ongoing community. So this example is also similar to the previous example. So let me take a right. So let me take the input x equal to yeah. So let me initialize two variables. One is x. One is x. I'm taking an empty space. I'm just initializing x. Okay. And let me also initialize y. So in this example, what does x stands for me? In this example, what does x stands for me means x is the type of traffic and what is actually the successful transmission rate, what is collision, what is delay, and what is throughput. All these parameters I will take as an input because these are all the parameters that is related to the ongoing traffic. And if I get these values as an input, what the Wi-Fi device should predict? It should predict the CW values and rate tracing. Okay. So I'm just copying it. Okay, I cannot take the variables, so let me just initialize the values like 1, 2, 3, 4 for all different type of okay. So first let me just take all the inputs. Let me take all the inputs. Now input is an array of totally 5 values, right? 1, 2, 3, 4, 5. 5 values, right? So let me copy this and So let me run this code. When I run this code, empty values of x and y will be initialized. So let me open the values of x. And here I copy whatever that I have taken from the Excel sheet. These values I'm copying to the variable x. Right? These values I'm copying to the variable x. Similarly, what are the variables that I have to take for y? So y. So these are the different values for with respect to y. So I'm just opening the output, that is y, and I'm pasting all the values here. Now I have the data, both inputs and outputs. Again, the story is the same. Just open the. Okay, let me just close this and do it again. So go to apps, search for neural fitting, neural net fitting. Import the data. Because now it is not a single column data, it has multiple rows and multiple columns in both inputs and outputs. So I'm choosing the inputs as x and outputs as y. Click on OK. Okay, you just the observations are row wise. Okay. Yeah, the data is loaded. The data is of size 10 cross 5 as inputs. 10 cross 3 is the output. Choose the validation data and testing data that is as per your choice. Now click on train. Yeah. So now the model is trained. Let me just create a simple training script. So this is what my simple training script is. So again, I'm running this code because you see my x, y's are being taken. And I'm using the default train LM as a training function, and all these are same. Let me train this again. Now, once I train with all my x and y values, so finally what I get? Finally, we get the net. Net is actually now the train model. Now, if you want the values of y, now for example, I have a traffic pattern. I have a traffic. So where this traffic is, this traffic belongs to the access category 2, right? So what is the other parameter of the traffic? Let this traffic has a transmission success rate as 50% or some 40%. And the collisions or some 10 collisions are happened. Average collisions are happening with this traffic. That also I am giving. So average some 10 collisions are happening. Then this traffic is experiencing an average delay of some 7 milliseconds, and it is experiencing a throughput of 1 Mbps. These are all the data that is related to ongoing traffic. Now what I do is, for this traffic nature, I want the values of contention window min, max and retransmission. How can you do that? It is simply the output is equal to, because my model is trained. My model is already trained, right? So you just check it here. What is the name of my model? Net. So to this, what should I pass? I have to pass the traffic. But I think you have to pass it in a column wise. Okay, let us check with this. Yeah, I think you have to pass it. You just transpose this matrix. Right. So, and again, I'm running it back. I think you can choose the output here. I got some output. I'm just copying it and pasting here. So this is the output that I got. So for the traffic of this nature, the minimum contention window should be 4.2 and the maximum should be 8.6 and the retrailing should be. That's how machine learning works. I have given a very simple illustrative example. Though it's a vague example, but you can easily learn how can you use ML, especially the regression part. Okay. So the rest of the things you can try by yourself. And the last few minutes we will discuss a paper related to the ML. Okay. This is a recent paper on this Wi-Fi 7, I think. Basically on MLO operation, multi-links operation. So this is a recent paper that is published in IEEE Internet of Things journal. Last year paper, very recent of this current trend. So the paper title is Adaptive Multi-Link Channel Access, and the cross-link interference in next generation wireless. I'm not going in detail about it, but whatever is required, I will be explaining here. So consider that a MLO architecture in the sense multi-link operation can be enabled in either at the access point or at the stations. At the access point, if you see, there may be multiple access points at different links with different frequency spectrum. Similarly, the non-access point MLD, which is so the non-access point MLD, which is basically the stations that are communicating with the access points at different links. Here, what I mean by the link means the different spectrum, that is 2.4, 5, and 6 gigahertz. These are the three different spectrums. So once again, a quick recap. What is MLO means? A station can simultaneously send or receive data at the same time at a different frequency band. So when your Wi-Fi has all these three frequency bands, you don't want to depend on any link. You can use all the three links for effective communication, which obviously reduces the latency like anything. Because ultra low latency type of communication and ultra high throughput kind of networks. So here, so in this paper, what they are doing is, generally there are two versions of non-AP ML. One is SPR, other one is non-ST. So if a device has a capability to simultaneously transmit at the same time to receive, this is called as STM. But generally, these capabilities are more suitable for access points because access point is a powered device. It is self-powered. But this cannot happen on a mobile device because mobile device mainly depends upon the battery. If communication happens in multiple links, it obviously drains the battery. So we cannot guarantee on a mobile device. That's why these types of communications are on mobile device, the type of communications are non-simultaneous transmit and receive. But when a problem comes is, if I am a device, for example, I'm communicating at 2.4 and 5 gigahertz. Actually, the band gap between them is very high. So obviously there is no cross interference between. But if I am transmitting at 5 and 6, then there is a huge chance that the channels may overlap or the band gap between the channels will be very less. You know that generally for 2.4 gigahertz, most of the channel bandwidth is the channels are each of 20 megahertz and the bandwidth is 40 or 80 megahertz. But when you use the Wi-Fi at higher spectrum, 5 gigahertz or 6 gigahertz, you have different bands. Like you can use at 40, you can use at 20 megahertz, or at 40 or 80 or 160 or up to 320 megahertz bandwidth is available for you. So when you are communicating at higher bands, the band gap will be very, very small. Then there is a huge chance of cross-link interference. That is called as cross-link interference. Okay. What this paper do is, this paper analyzes considering a station as non-STR, and it proposes a Markov chain model to analyze its transmission probability throughput. And in case of multi-link operation networks, generally it is as the communication happens as a carrier aggregation, because simultaneous transmissions and the overall throughput is the throughput on each link. So what the overall throughput is? Summation of all the individual. This is called as carrier aggregation. So here what is ఇక్కడ మూడు రకాల పీడిఎఫ్ ఫైల్స్ స్లోగా పోలేదు అవుతాను అక్కడ స్లోగా ఉంది
సారీ రీషేర్
నెట్వర్క్ స్లోగా ఉంది
లేదు సారీ సార్ రీషేర్
సార్ వస్తాను మళ్ళీ షేర్ చేయమంటారు So here, whatever the initial Markov chain model I have explained, this is also a Markov chain model for ML. Especially this is for a non-STR device. So very easy, because see, before decrementing, what will happen is, if there is any, the only difference between the previous diagram, in my slide have shown, right, and with this, whenever a device is decrementing, if there is any cross interference, especially when a device is transmitting at 5 and 6 gigahertz, if there is any cross interference, it changes to a state. You can assume that this state is like in a busy state, it waits there. And if there is no any cross interference, it goes back and the decrementation process. That is the only difference between the original DCF which I have explained and the DCF with respect to this ML. Let me just quickly show one last result and we will wind up this. Yeah, you can see here. So this is a throughput for link 1 and link 2. You know that whenever the number of devices increases, what happens to the throughput? Just now I explained. If there is a person, the only person downloading a movie, obviously 100% of data rate he gets. Throughput is nothing but data rate. But if the number of users are being shared, I mean, if the number of users increases, the channel is shared. When channel shares, obviously the contention increases, collision increases, cross-link interference increases, everything increases. So the throughput gradually decreases. And what this graph shows is, as simultaneously, there is two transmissions happening, but there is a cross-link interference because the bandwidth is very small. In such cases, what will generally happen to the throughput is this is what happening to the throughput. The throughput gradually decreases, but it will remain same after some point of time, and the network size considers a 20 devices in this case. But as there are multiple links, how can you calculate the aggregate throughput? It's simple. The aggregate throughput is nothing but the summation of all the throughputs in every. So this is a very simple part. How to plot these things means it's completely based upon the model that I had initially shown. You have to solve the model, find some probability transitions, then find a stationary probability, then compute throughput and all. It's a step-by-step process. But however, I will be sharing these slides and this paper to you. Please check it once. So with this, I know that this topic is little complicated, but it's a good to try once. So thank you very much.